So, multiplying polynomials part 1. This actually is split up into 3 parts. You will get part 1 tonight, part 2 tomorrow night, and then part 3 the following night. So you're going to have 3 in a row. This is the heart of what we're doing and why we learned all of these exponent rules and all of this stuff. Basically today is nothing more than distributive property like you have been seeing and been doing before. So if you look at this first example, this is just a distributive property problem, but you have to remember your rules that go with multiplying with exponents. When you multiply with exponents, you have to remember that what you have to do is multiply the coefficients and add the exponents. We're going to do distributive property here. So we're going to do x times 2x. Now if you remember, these have little invisible powers of 1 on them. And so x times 2x is 2x squared, because when I add the exponents, 1 plus 1 is 2, plus, because that's what I have here, and when I distribute this x to the 4, y'all should know that that's just 4x. Now if you go back to what we did yesterday or today in class, you will see that I cannot combine these because this is an x squared and this is an x. So this is the simplified version of that. I've just distributed my x to everything. That is your expression. That is the final simplified answer. So let's try another one. We're going to have to distribute this 5a to everything in parentheses, so I have to do 5a times 2a. We'll multiply coefficients. 5 times 2 is 10, and then you have to add your exponents, so you add the 2 little invisible ones, so you end up with 10a squared, plus, now 5a times 3b. These are not the same base. I have an a and I have a b, but I can still multiply them. I can do the coefficients. 5 times 3 is 15, and then a times b is just a b, because this means 15 times a times b. And since these are not like terms, I also cannot add them together, so I'm simplified. So all this really is just distributive property, nothing really big, fancy, or new. This next problem is written backwards. The thing you're going to distribute is to the right instead of on the left-hand side, but you're still going to distribute just like you have been. So I'm going to have to do 0.5y times 0.5x. Well, 0.5 times 0.5 is 0.25, and then x times y is xy, plus, then you have to distribute to here. So you have 0.5 times y, 0.5y times y gives you 0.5y squared, because you added the 2 invisible ones. Now the next one's not any different, except it's longer. You're going to have to distribute 3 times instead of twice, but it's the same exact principle. You're going to have to keep up with bases and exponents as you go here. So watch what you're doing while you're solving this one. So here we go. We'll distribute here. Negative 3 times positive 3 is a negative 9. X times x squared is x to the third. So I had to add exponents. And then y times y is y squared. Now I'm not going to put my plus sign yet. I thought I was going to, but I changed my mind. So I'm going to multiply first. Negative 3 times positive 6 is a negative 18, so this becomes a minus sign. You could put plus and negative, it's the same thing, but I don't like double signs. And then x times x is x squared, and y times y is y squared. Now when I distribute here, negative 3 times negative 5 is a positive 15, because this minus sign and that minus sign make a plus, and then x times x is x squared, and y times y squared is y to the third. So there is that one simplified. All you have to do is multiply your coefficients and then keep up with exponents on your individual bases. Let's do just a few more. This one combines what we're doing today with what we did yesterday, because you see you have this minus sign in between the two, and when I'm all done I'm going to have like terms that will have to be combined. But let's just take it half at a time. So this 2b is in front of this set of parentheses, so it gets distributed just to this set of parentheses. So you have 2b times b squared, which is 2b to the third, and then 2b times 4b is 8b squared, and then 2b times 8 is 16b. So this has been distributed. We are now done. This is the second half of the problem. When I distribute here, I'm going to have to distribute a negative 3b through, so I can take care of this minus sign. So I have negative 3b times positive 3b squared gives me a negative 9b to the third. Then negative 3b times positive 9b is negative 27b squared. And then negative 3b times negative 18 is positive. Yes, y'all busted me. I had to whoop out the old calculator. Becomes positive 54b. Now, I am not done with this because if you will look, you see that you have like terms. You have 2b to the third minus 9b to the third. So I'm going to go ahead and subtract. That gives me negative 7b to the third. Then I have 8b squared minus 27b squared. And when I do that one, you get minus 19b squared. And then you have these left. You have 16b plus 54b. So it's going to be a plus 70b. And so that's what that one ends up when you have to simplify. I distributed first and got this really long expression, and then I had like terms, so I put all the like terms together, and this is my final simplified expression. If you stop right here, you have not simplified all the way, and you're going to lose points for that. I put the next one in here because anytime fractions show up in a problem, everybody gets all nervous because it's a fraction, but these are actually easy fractions because all of these are multiples of 5, which is what you're distributing. So I have negative 5x squared times 1/25 x squared. Well, I'm going to be able to cancel out here. It's going to be negative, and then this becomes 5 over 25, which is the same thing as 1/5. Okay, so I can cancel out. So I have negative 1/5 x to the fourth because I added my two exponents. Then distribute to here. This negative and this negative make a positive, so I have a plus sign. This one also becomes 1/5 because it's 5 times 1/25. And then my x squared times x is x to the third. And then negative 5 times positive 1/5 is negative 1x squared because the 5's will cancel each other out. So here is my simplified expression. I can't put anything together because I have an x to the fourth, an x to the third, and x squared. You can't do anything. If you wanted to get really technical, you could write this in the proper, well, it is in the proper order. You could talk about the degree that this is. This is a 4th degree polynomial because your biggest exponent is a 4, but that's not really something you're going to have to know in order to do your homework tomorrow. You are simplified. Let's just try one more, just to see how this could be applied somewhere where you'll see it in a word type problem. You have to find the area of the shaded region in simplest terms. So you have this rectangle with this little square inside, and we got to find the shaded area. Now this is just like what you did in 7th pre-AP. You have to find the area of the whole thing and then subtract out the part that's not shaded. So the whole thing, to find the area of a rectangle, you do length times width. So I'm going to have to do 3x times 4x minus 6. So it's just a distributive property problem. 3x times 4x is 12x squared. 3x times negative 6 is negative 18x. And so that's the area of the whole thing. Then I have to do the square. Area of a square you can also do as length times width. So I have to do x times x. And y'all should recognize that that is x squared. So here's the whole thing. Here is the square. I'm going to have to subtract them in order to get the shaded region. So I have 12x squared minus 18x minus x squared. This should not be an x squared. This should just be an x. There you go. So like terms, you're going to put them together again. I have 12x squared minus 1x squared, which leaves me with 11x squared minus 18x. And there is the area of the shaded region of that picture. We'll have a warm-up tomorrow that covers a couple of these things. Please make sure that you have your notes, as I will be checking them to make sure that you have them. And I will see you guys tomorrow. Have a great evening.